Okay, so I want to work in a little bit of math stuff for you guys, and I'm feeling bad because I'm like, well, they'll figure it out. Oh, you didn't. Some of you. And like I always say, you don't have to really know math well because I'm going to bring you up into it. But I am going to throw this out there. If for some reason you don't start, you need to take a math class. And so American River, Sacramento City College, Cosumnes River, Folsom Lake, I mean, we're all the same district, okay? So it's all like the same school, just different names. I am taking some math classes over at American River because I get credits for advancement in my pay grade. So I don't want to say City College doesn't, but they have a great online math program. And I basically just went and said, I want to take the Math 1, the beginning, and literally it was, okay. And it's like, okay, this is how you add numbers. See, there's a 1 and another 1, and there's a 1 and a 1, and this means plus. And what you're going to do, you can put these together. It's like one, and that's where it starts. So, and then it moves on from there. But if you haven't done math in a long time, you haven't done, put a string on it or something for you can pull it back. So if you haven't done math in a long time and you don't get in the program, that is what I highly recommend you do because it's kind of a self-paced great thing. Yeah.
Any math level you recommend starting at that would be most relevant to what we do here?
It's really, really helpful to start with a math that is fractions.
Fractions. Okay, so like algebra 2, something like that?
No, it's like before algebra's fractions. So it's still, that's a basic math. So I forget what number it was, math 141 or something like that.
Okay.
But it's the no prerequisite, everybody's welcome. And there's a book you buy over there and it covers like 4 different semesters. I mean, it's a good value. But I'm going through it right now and I'm like, wow, I've learned a lot of teaching tricks. I think it's great. It just gets you in numbers because a lot of people get stressed about numbers. I don't want you to be. Because really, we can start with some simple stuff. What is this sign? Plus, all right, which stands for addition. What else does it mean? Add. You see the word add. How about the sum of 2 numbers? Now you might hear that. What are the sum of 2 numbers? That means add. All right, of course, when we all know stuff like plus and increase. A number increased by 4 means a number plus 4. Increased. And this, of course, is subtraction. Subtraction, minus. Less. Very good. Less. Difference. Difference. I've got that written down here. Take away. You know what? And I'm fine with that. We can bring this because, like I said, I'll never make fun of somebody for mispronouncing something. Because somebody once said, never ever make fun of somebody mispronouncing something. It's because they learned it in a book, and by God, they're out there reading, doing the best they can, and that's the person you make fun of. No, I don't make fun of people. So you can mispronounce stuff. Sometimes I'll like make a little bit fun, only because I really like the way you said it. Like some people say micrometer. I think that sounds kind of cool, and I'm like, why don't we call it micrometer? I kind of like it that way. Then I'll start calling it that, and then I'm like, wait, then I can't say it right. This, of course, is multiplication. Multiplication is sometimes shown as a dot as well.
Yeah.
Multiplication, times. Product.
Yep.
If I had to remember a word, I would say product, because sometimes you'll see the product of 2 and, well, not 2 and 2, because that's the same thing. But, the product of 2 and 5, you're like, wait a minute. The product of 2 and 5, well, is that 2 times 5, or is that 2 plus 5? Which one is it? 2 times. All right, and then division. Something I never thought much about, division, this little symbol right here, it's just simply a fraction. I'm like, whoa, it is.
Yeah.
It's showing you a fraction because a fraction is division. All right, so that's division. Division, divide. Quotient. Quotient's your big term there. Quotient goes into times, all that kind of stuff. All right, then we have to remember that that especially in aviation, I should say especially, but we do. In aviation, we deal a lot with positive and negative numbers. And the reason why that is because aircraft are actually given a station number. So, and a station number is defined as, at least American planes, inches from a certain point. And so a lot of times it's the firewall, the piece of sheet metal between the occupants and the engine. Especially if it's a single engine, it's all in one thing. If it's a twin, it's firewalls are out there. But that firewall can be a division point, and everything behind the firewall is given a positive number. So if I said, well, if the seats are located at plus 36, I go, okay, I go to the firewall and I count 36 inches back and there's the seat. It says, but the propeller is located at minus 42. Well, that means the propeller's out here, right? So plus and minus. And so then we get into weight and balance, which is critical at aircraft, is you're going to end up doing a lot of math with that. You have a plus like you have a plus station, plus 36 where the seats are, but you remove something. So it's plus that, minus what I've removed, equals, and then you get a moment, which is something you'll get into. But you just have to remember that you're dealing with pluses and minuses, and you have to work them properly. And there are, of course, rules. So if I want to talk about some addition, see if I can trip you up. A positive number plus, because I can't put a positive number, that looks like a plus, is always going to equal a positive number. Because a positive 2 and a positive 2 is a positive 4. If I have a positive $20 in my bank, I hope I do, and I add another, I get paid, and I add another $100, then a positive 20 plus a positive 100 should equal a positive, except my wife is going to get involved, and that's not, okay, so a negative plus a negative number equals, it's always going to be a negative number. So if I have negative $20 in my bank and Katie goes to Starbucks and uses the ATM card, I don't think it works that way, but they pull out another 20, then I'm now a negative 20 plus a negative 20 is negative 40. Right there. Okay. But what if it's mixed? What if I have a positive plus a negative? Positive plus a negative. Well, it depends. Depends on which one was bigger, which one was smaller. So because we're always going to think about the number line. And if this is 0, and this is negative 1, negative 2, negative 3, negative 4, and this is positive 1, positive 2, positive 3, positive 4, and I have a negative, we'll say negative 4 plus 1. Well, that's still negative 3. It's just going from this spot to that spot. If I have I'll say positive 2 plus a negative 6, I'm going to get negative 4. All right, so what I always want you to be able to go onto your calculator, because when you take your test, and top left-hand drawer of my toolbox, guess what's right there? Calculator. I can do numbers in my head. Everybody can do numbers in your head, but this is aviation. I don't want to make mistakes. Double check myself. So make sure you understand how your calculator works.
You can do 2 plus a negative 6.
Oops, I didn't want that. I want the calculator. There we go, calculator. So make sure you know how your calculator works. If you have this one, it works one way. If you have the one Hannah has, it works different. So I've just switched to this one, so I got to get used to it. But what did I say a minute ago? What was it?
2 plus negative 6.
2 plus a negative 6. So 2 plus negative 6. Yeah.
If anyone has my calculator, I have this little sheet that explains everything on my calculator. So, yeah. Does everyone have it?
Yep. Okay. You've just made the assumption that somebody is going to read directions. They don't read directions.
Oh.
Okay. So if I want to do that, it's 2, and then the plus 2. Let's see. 2. Make sure everybody can. 2 plus. It's this right here. The minus. Negative 6. 2 plus negative 2 plus negative 6. On the other calculators, you do it backwards. It's 6 negative, and that equals negative 4. So You know, don't let something stupid like that get to you. All right, move on from that. Let's see. I don't have a lot of time to go into that, so I'm just going to kind of move on to where some of our trouble spots are. I want you to make sure you know how to use the negative function on your calculator. We'll do a lot more with math when we start electricity. The entire first week is just basic math. And I'm going to walk you right up to where we need to be. So, all right, so fractions. Used to hate fractions. Now I love fractions just because now I understand them. And so when we talk about fractions, on the top we have something called a numerator. And what goes on the bottom? Denominator. You know how I remember that? There's an N and a D, and this is D-O-W. Now this T. That's downstairs. The D just goes downstairs. What's that? Oh, N is north. Well, that's good. North is up. I always wondered what that. Downstairs.
Not downstairs.
What?
You said not downstairs.
Not. Oh yeah. Oh yeah. Not downstairs. Hey, that works. There's pointed in and not pointed in. All right. Those are transistors.
Where are you at? There. Up or down?
All right. But anyway, you know, it's stupid things like that. I'm not ashamed to admit it. I'm also not ashamed to admit sometimes you get into this little bit of test anxiety, or just, I don't know, a little brain infarction. And that's why I love 1/2. 1/2 is my favorite fraction. How many of you guys have a favorite fraction? I've got a favorite fraction. Because 1/2 is equal to what decimal place? 0.5. All right. Most of us know that, memorized, it's easy to work with. So when I get into something like that, I remember that fractions are a division problem. A division problem. And then you go, wait a minute. Is it 1 divided by 2, or is it 2 divided by 1? Is it 1 goes into 2, or 2 goes into 1? I got to pick one of those. And so I go, whoa, wait a minute. But I know what the answer is, right? The answer better be? So if I had some other number like 365 over 720, I'm like, wait a minute. Is it I forget what the answer is. Which should the answer be? I can go to 1/2 and go, wait a minute. Okay, 1/2's got to equal 0.5. So I can look at this, and should I go 1 divided by 2 equals 0.5? Okay, it's 1 divided by 2. That's the right one right there. 1 divided by 2. And so it's this number, the divided 2. Then, all right, follow me what I'm saying? If you get kind of confused about something, then I go, wait, is it 1 into 2 or 2 into 1? Well, then you can just look at that. Why do this? 2 goes into 1. Oh, yeah, if I have 1, it goes into 2 a half a time. So then it makes sense, right? Or actually it doesn't. So it's the other way. So 2. So do this out. How many times does 2 go into 1? 2 times. Okay, that's not the right answer. How many times does 2 go in that? Well, I get 0.0. So that, it goes in there 5 times. So 5 times 2 is 10. So, oh, yeah, this is the right way there if I'm doing it longhand. You don't have to do longhand. Hopefully that made some sense because I went through it really quickly.
The top number is inside the house. The bottom number is outside.
All right, but if you forget,
Yeah.
this is how I remember. And I will. I always have a scratch paper, and I'm in the middle of a test. I'm just going, I'm stressed out. I don't know what to do. I'm like, I'm just going to be stupid about it. I'm 0.1/2 and 0.5. I'm working on my calculator and go, okay, I remember how to do it now. I'm cool. I'm
As
good.
long as you have the right answer.
All right, but I like to tell people it's okay to back up to something so basic and so simple and just get your mind engaged where it's got its first gear, right? Just got to get your mind engaged. Okay, I know, I've got this. Then come back out fighting. I know how to do this, all right? So let me see, where do I want to go with that? So fractions. So it is a division problem. So it's the 1 and then divided by and then 2. What's the answer here? 365 divided by 720. It's also 0.5. All right. This is a proper fraction, but if I had 2 over 1, that's not really a proper fraction. The answer is what? It's how many times does 2 go into 1? Well, guess what? That just equals 2. But anytime you have the 1 below it, that just means it's the number. But what you're going to be asked to do a lot is to manipulate stuff. So change fraction to a decimal. All right, so if I want to change a fraction by decimal, we just talked about how to do it. I How do I change 1/2 to, or any number? 365 over 720 is my fraction. How do I do, what is 3/8 change to a decimal? Okay? I usually don't give 2 ways to do something. I'm like, we're just going to do it this way. You can do it any way you want to. Just keep, I'm teaching to the person who's struggling. All right? And so I always want to say, okay, if you're struggling, and you're like me and you're struggling, let's just do it this way. We're going to do it one way. You don't have to have a whole, but there's 2 ways, and you just got to know it. So 2 ways to change this. What are my 2 ways? Just do it. Just do the division. It's 3 divided by 8. So this, we can do 3 divided by 8 equals 0.375. All right, that's cool. The other way to do it is to use our calculator. And we're just going to go 3, this ABC key right here, which stands for fractions, ABC 8. So 3 ABC 8. Let's see what I'm doing here. Hopefully you have a calculator doing it. 3 ABC 8. And then I hit equals, and then, well, I don't have to equals. Let me do this. Okay. 3 ABC 8. And then we would hit the second function. And then this right here, fraction decimal. FD, fraction decimal, second fraction decimal, equals 0.375. So everybody see that key right here? Fraction to decimal, right here. That's your friend. Want to know how to change a fraction to a decimal? Hit that button. Want to know how to change decimal to a fraction? Hit that button.
What about a percentage to a decimal?
What's that?
A percentage to a decimal.
A percentage to a decimal. Okay. Well, the thing about a percentage is that it means out of 100. Out of 100. So 100%. What does it mean if somebody says you should give 110%?
More than what you got.
It means they're not really good at math. Because 100% is equal to 1. So to change a percent to a non-number, you just move the decimal places 2 places to the left. So 100% equals 1.
Smiley face.
Huh?
Nothing.
It is a smiley face. Look at that. Because he's happy you're all here.
It's like Garfield.
A little bit. It's the best drawing I've ever done. All right. So we want to do, Sharice, what? A what to what? What do you want to do? Percent to decimal? I think I just did that. There we go. So really, you're just going to move it 2 places to the left. So give me any 65%. What is 65% as a decimal? This would be 0.00 if I want to do it right. 65%, I move it over 2 places to the left. So it's 0.65.
If you have
So if
5%.
Well, hang on. Hang on, let me talk to Sharice.
So if it's like, say, 379%, I'm not saying.
Not 379%, 379%. That's your discount this week. Okay.
Would it be 3.79?
It would certainly be 3.79. And so, where you like to shop?
What do you mean?
Fine, Walmart. Because wait a minute, you guys know why I like Walmart, right?
Yeah.
I told you.
Shareholder.
Huh?
He's a shareholder.
Because,
This is my son. My son works at the headquarters in Bentonville, Arkansas. So, and you go to Walmart and they say, well, we've got, which should we buy? Which should we buy at Walmart?
Socks.
We got it. We got a big screen TV this week at Walmart. Regularly $375. Her dad just bought a TV that's it's this size. I forget what he paid for it. It's insane. It's like, oh, look what I got. So 375%. Sorry, it's $375. This week it's 15% off. Well, how much you can pay for the TV? Okay, so
Actually,
maybe I don't want to get into this yet,
I
but
think
it's
it would be 365? No.
okay. It's do this. You do 375 times, and the easy way to do it is times 15%. Now, you don't necessarily have to convert it. You can actually go times 1/5 percent times 1/5 percent equals, and it's going to tell you your discount is 56.25. That's how much you're going to.
$369.38.
And so then you would subtract 56.25 from that. We'll get more into this kind of thing in the electricity class, the week we do math. I'm going to teach you how to solve every single FAA word problem with a ratio. It's just that simple. I don't know. I figured out one day, word problem. I'm like, wait a minute. There's a key to every single one of them. If you set it up like this, done, solved. They're all. It's just so easy. You're going to laugh at it when we're all done. So we got good things coming. All right, working with fractions, fraction to a decimal. All right, this is something I really wanted to get into here. And this is applicable to especially you guys working on your torque plates. So you're working on your torque plate, and I told you to use a dial caliper, and you take a bolt and you measure the bolt, and you look at the bolt and you go, well, my bolt just measured 0.248. All right, possible. And you want to convert that to a fraction. Well, how do I convert that to a fraction? Well, the first thing that I want to ask myself is, what fraction do I wish it was in? Now, I'm working with bolts, so what size fraction do I wish the diameter was in?
16.
I want it to be in 16ths, right? Everybody know why?
Because that's the way they bolt.
Because that's the way the bolts go. Diameter bolts is measured in 16ths. So I wish it would have been in 16ths. Well, your wish has been granted. If you multiply 248 times 16, which is the decimal or the fraction I wished it was in, so 0.248 times 16, my answer is that equals 3.968. 3.968 what? 3.98 sixteenths. Well, is there a bolt called a 3.968 sixteenths? There's not, but what if I round up a little bit? If I round this number up. Rounding up means if it's this, say when you round up, I just learned this in the math class. I knew how to round up, but I like what they say. Put a line under the thing that you want to round to. So I only want one number. I want this number to be, and then look at this one. If it's more than 5, more than or equal to 5, you go up. If it is less than, which is also this symbol, less than 5, which means 4, 3, 2, or 1, then you go down. So this number, is it more, equal to, or greater than 5? Greater than. So this becomes a 4. So the answer is 4/16. Guess what size bolt it is? Quarter-inch bolt. So, well, I don't know. How's that quarter-inch? That's fine. I got my calculator. Oops. So I can go, well, I don't know. Not very good at fractions, but I got, what did I get a minute ago? 4/16. Is there a 4/16 bolt?
Nope.
Well, it's a -4, or a 4. It's an AN4, so it kind of helped, right? But if I want to use regular values, I go 4 ABC 16 equals. Oops, I did it right. 4 ABC 16 equals quarter-inch. Yep, did it. Equals quarter-inch. So that's quarter-inch bolt. What if I measured one and I came up with 0.371? What size bolt is that? I want to multiply it times what number?
16.
Times 16. 0.371 times 16 equals 5.936 sixteenths, which is almost the same as 6/16, which reduced, if I don't remember how to reduce, it is 6 ABC 16 equals, and it just tells me 3/8. Look at you, the math whiz that you are. What if I told you I want you to add 1/4 and 7/8? All right, now you know if you want to do it longhand, you got to convert this 4 to an 8, right? So multiply times 2, so that becomes 2/4. So the answer would be 9/8, and then I'd have to 8 goes into 9 one time, so it'd be what 1 1/8 if I did it longhand in my brain, right? Let's see if I'm right. The way to do it is how?
1 ABC 4 plus 7 ABC 8.
You got it. And what's my answer?
1 and 1/8.
1 1/8. Look how fast he was. You guy's better at math than I am, that's for sure. He just whipped it out just like that. What's that?
Can you go back to that last slide? No, not that one, the one with the calculator and the numbers.
Oh, I just erased it. Okay, so remember that's to add fractions and so we can do that. We can add fractions now. You can divide fractions. You can multiply. Once you know that ABC button, you're locked in. All right. And remember, if you look at the ABC button very carefully, above it, it is ABC, and then it's got the arrows to DE, I think. DE. What that's saying is it's a mixed fraction, like 1 1/8, to a not mixed fraction, which would be 9/8. So if you did the math on there and you were working your calculator and you did get 1 1/8, then you could try it. If you didn't, how would I plug in 1 1/8 on my calculator?
1 ABC 1/8.
1 ABC, 1 ABC, 8. You got to hit that button twice. So it's 1 ABC, it's going to put a comma. 1 ABC, another comma, 8. Now if I hit equals, it just says 1 U 1/8. So my display is 1 and 1/8. Everybody follow that? I'm not moving too fast? Not moving too slow, I hope? Okay.
What does U stand for, though?
I don't know. It's just like a
Space or something?
space or parentheses.
1 Wouldn't that be 1 divided by 1/8?
All right, we covered scientific notation, but I'll just do this and we'll take a break. But I didn't tell you how to do it on your calculator. So scientific notation on your calculator is very simple. But you need to get used to using it because as soon as you get into electricity, you're going to see that you're already dealing with milliamps. So if I want to do something on my calculator in scientific notation, okay, so first of all, scientific notation, let me see here. You have to remember that the base front number has to be a number between 1 and 9. So if I want to look at 6.875 times 10 to the third, that's scientific notation because is proper scientific notation because this number is between 1 and 9. If I said 68.75 times 10 to the second, same number, but it's improper because this must be a number between 1 and 9. Is that a number between 1 and 9?
No.
No. Is this a number between 1 and 9?
Yes.
Yes, so that makes this proper and this improper. And in scientific notation, this is telling me how many places to move the decimal place, right? So, so the answer is 1, 2, 3. So that equals 6.875. Let's see if I'm right. All right. So how can I plug in 6.875 10 to the third? Okay, it's 6.875. Okay, we're going to hit the second button, and we're going to look for right here, this EE. Okay, that's an X. That means times 10 to the whatever, I guess. So I shouldn't say I guess. It's what it means. So 6.875 second EE. I think if I had equals, it might. No, we didn't. That's the number. I haven't much thought about how to get. Oh, I know. EE. Duh. So 6.875, the second function, the EE. Then I've got to get 3. EE to the third. So you don't have to put the 10. It's just EE to the third. And I think if I hit equals, yep, and then hit, if I want to, I could hit equals, and it's just going to say it's, oh, well, that's 6.875 there, Kevin. Did everybody follow how to do that? Scientific notation? Okay, that's forward scientific notation, or I shouldn't say forward. Maybe I should. Who knows? I'm going to erase this. But what if I'm dealing with something like milliamps? All right, so if I said I have 652 milliamps. Well, milli, that's scientific notation, right? We talked about that. Anybody remember what it's the 10 times? It's times 10 to the negative third. Negative third. All right. So what is 652 times 10 to the negative third in a not scientific notation?
0.652.
Well, how can I do that? Well, same thing. It's 652 second EE negative 3. Everybody follow that? 652, so clear. 652 second EE negative 3 equals, that is 0.652 amps. I hope everybody can see that. It's the same thing as saying, what is 652 times 10 to the negative third? Is this proper scientific notation? It is not, but it's a real number. All right, what is this number written out without the times 10 to the negative third? Why? It's 0.652, because the negative 3 tells me to go backwards 3 spaces. 1, 2, 3. 652. I often call this unpacking when I see a scientific notation number like 0.652 times 10 to the negative third. And I say, well, you got to unpack it. And what I mean by unpack it is you got to make it into a normal number, a number without times 10 to the third. And when I say unpack it, I want you always stop and look at this exponent right here and say, okay, if it says negative anything, is the number going to get bigger or smaller? Smaller. Now, you might have more digits, but it got smaller. So right here I said 652 times 10 to the negative third. When I unpack it, is the 652 going to get bigger or smaller? Because it's smaller. Is 0.652 smaller than 652?
Yeah.
Then I did it correctly.
But wouldn't that be 6.52 times 10 to the negative there?
It is. It's 652 times 10. This is the same thing here.
Yeah. All right, I was saying, that was the problem, 62 times 10 to the negative third.
Yeah.
Would that be more great? Like, if that was the problem, it'd be 6.52.
No, it's point is what? You lost me.
Because remember, there's always
Hang on, I can't hear him when you're trying to explain what he's trying to tell me.
Like you said, in scientific notation,
Yes.
there has to be one
Oh,
number in front
yeah,
of the
it's
decimal point.
proper
from
would have
1
been
through
point.
9.
Okay.
So it'd be 6.52 times 10 to the negative.
It would if it was in the 10 to the negative third. It is
Yeah.
proper for me to say 652 milliamps. There is nothing
Yeah.
wrong with that.
No, of course.
Okay. But if I was going to write out times 10 to the negative third
It'd be,
in proper scientific notation, you should do it.
so it'd be like 6.52
It would be
times 10 to the negative second.
Second, it would, yes. But I think some people just went, I just got lost on that
Yeah.
one. You're okay. Don't worry about what he said. He's right, though. He's right. If you did follow along, he's absolutely right.
Well, there's supposed to be one number in front of the decimal.
Supposed to be one number, but
As
when we
long
talk
as
about,
between 0 and 9, you're good.
yeah, we're talking about milli. And it doesn't matter if it's proper or not. You need to know how to get it in and out. All right? And I don't want to take a lot of time because you have your math worksheet, which had you go in and out in the book. And if you have problems with that, make sure you ask one of us. I'm just trying to cover some real basic stuff here so we can move on and I'll be on the same wavelength with stuff. And we're going to go over more calculator stuff, and don't ever be afraid to say, okay, wait a minute, how did you just do that on the calculator? Because I want you to become extremely comfortable with your calculator. When you take your tests, I want to be your little buddy right there, and this will be your calculator, and you have it. I had this calculator all through my A&P school. So I still have my calculator at home.
The souvenir.
Let's see, you guys okay for a couple more minutes?
Yeah.
Okay. The FAA, I don't write trick questions, the FAA does. And they love trick questions. I don't love trick questions, but I love questions where you have to think. And like some of my favorite are when you have something like this, and I say, this is 36 inches, and this is 12 inches. How many square feet are in there? And then you say, wait a minute, I know how to do this. 36 times 12 equals 720? 36 times 12 is 432. And you say, okay, 432, that's 432 inches. And I'm very smart, and I know that there are 12 inches to every foot. Therefore, I will do 432, and I will divide it by 12 because there are 12 inches in every foot. And the answer is 36. And I am such a smart guy. And then you think about it, wait a minute, this is 36 inches by 12 inches. How many square feet are in there? Well, let me see. There's 1 foot from here to here, and there's 3 from there to there. So this would look a lot like this, and I count 1, 2, 3 square feet. How did you just get 36? Huh? All right. No, not cubic.
No. I'm sorry, square.
Square. It's square. All right. Let's take a look at one of these square feet right here. If this is a square foot and it's 12 inches by 12 inches, then that means there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines there. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines there. So how many actual squares are going to be in here? Exactly 144 squares. Therefore, you should have never divided by 12. You should have divided by 144. But I don't do that. I go back to the question, and I'll get a clean piece of paper. And I say, I've got, oops, we don't need that there. I've got 36 inches, and I've got 12 inches. And the FAA, the test question says, how many square feet? The first thing I do, convert it. That's 1 foot, that's 3 foot.
Now you just do length times width.
Now it's length times width. So always look exactly what is the question asking you and convert. Now when I write a test, I'll probably be more tricky because I would do something like, this is 24 inches and this is 3 feet.
Oh, yeah.
And then, you got to convert it one way or the other. Which way should you convert it? Look at the question, what it's asking, and convert it to the final answer up here, and then do it. Yeah.
When you write it out, do you have to do like square feet, or could you do like the slash
Feet squared.
like the single slash square?
Oh, you mean when you're doing your answer?
Yeah.
Like if your answer is like 36 feet square, or should you do 36 slash?
Or no, like 36, like, or
36 feet.
yeah.
Well, actually, if the answer is 36 feet, then you would have to put either the dash here or the feet. If it's feet square, then you got to make sure that little square is in there. You got to, or
yeah.
feet square. You have to get the proper notation. But I don't care as long as I can understand it and it makes sense, which presents a problem for you. I have to understand it. His
You
writing's a
need to
little
be able to
sloppy.
write it, or see it.
My reading of his writing is sloppy. There's nothing wrong with the way he does it. It's just my eyes are yet to be calibrated to his style of writing. So it's on me. I'm sorry about that. I'm working on it. And the more I look at it, the more my eyes get calibrated to it, and we're getting in sync. It's working. Another year or two, and I'll have it down pat. So. Because I do. I'm like, hey, your writing's getting better. And he just kind of laughs. No, it's not. You're just getting better at reading it. So, okay, let's take a break.